Welcome everyone. Are we live? Now we might be live. Welcome everyone to another low-level live stream. A little bit running out of time today, so only a brief update here of this amazing fun project that is this Pico RISC-V here on the FPGA. And if you're new to this channel, we do here various low-level stuff and hardware, software, you name it. And our latest toy and hobby here is this FPGA with an open source toolchain and of course RISC-V, because RISC-V and future and everything. So the update, welcome everyone. Thank you for asking. How are you? We are having quite some fun here. So the update from the last time, you have seen the previous videos. We have here running open source, open hardware, RISC-V, and as per the previous video, now also without any issues. So the last issue, the last video, I commented this already. This was just the pixel clock to our memory here. We run this here again, 32-bit RISC-V core with some VGA text mode output stuff. And what I've done today, so one question to summarize this here, I mentioned here, I brainstormed previously if this would not be maybe potentially a cooler or future-proof project. You might have seen on YouTube this 8-bit guy. They're doing some CX16 Commander 16 or something, not to confuse with Commodore C64. And I was thinking this other project, of course, amazing achievement, also a nice project from them. However, of course it's using, or of course they are using a 6502 or something similar CPU and this somewhat vintage architecture. And in my opinion, although the 8-bit guy specifically said in his videos, he specifically did not want an FPGA exactly for not having it reprogrammable, not making his CX16 into a Nintendo whatever game console emulator. However, I'm not afraid of this. It's nice reuse of hardware. So my idea is having here some side project for you maybe to play along at home. This system is in some parts right now, even with this icebreaker. So previous videos, this is 1-bit squared Eston's icebreaker FPGA board for $79 or $69 that you can get there to play along at home. And maybe I check with Eston, they are making PMODs, so right now this is even an HDMI. So in some ways, this setup here, off the shelf, super low power, super compact, already some better properties than the CX64 or 16 it is, I think it is. Because so not only we have HDMI, we also have a more modern CPU here, not a 6502 something, but a modern Pico RISC-V. And this, in my opinion, makes this already more interesting. Also, instead of BASIC, they of course, they use BASIC. Not the greatest BASIC fan here. We would certainly more use something like Lua or something. Just some brainstorming. Leave me in the comments below what you think. The only thing is where we are right now a little bit lacking is graphic power. Also, we have our mighty 16 color text mode. That is because we are memory limited. However, there is a PMOD like this plug-in module thing there for more memory, flash and memory. However, not only is this workable in this shape and form, it's just, well, not so many pixels, so whatever. However, maybe I check with Eston if he's interested. Maybe we can make a more memory possibility, something spin of this for more video memory. Aside from this, what is right now missing? So the next steps is sound and keyboard. We will do this next sometime soon. Only wanted to give you a brief overview. Also amazing RX32 SoC. Also, if you were wondering, is there some stuff? Are there some characters missing? No, they are not. It's just black on black with our amazing. So we can already cycle this here. Yes, it's a little bit off by one, but this is video signal generating. So this is just as you see here. The characters are there, just black on black because we iterate there over the colors, so some colors are black, foreground, black on black. That is certainly pretty black. I made here some changes, so also leave me in the comments below how much low-level stuff you want to see. The good thing is all this code, we will share this in this, I will maybe soon rename it. We have previously done this code if you're interested in this low-level stuff. Previously done this code of vintage DOS stuff, and I of course recycled here already at least some Printf, so that is a firmware here running on the RISC-V. The upstream firmware I only modified it a little bit for the video mode testing there. And today also making upstream code, I checked already with the authors here of the Pico RISC-V if they want some changes, because they had here, because this is a very low-level boot environment, they had here some very minimal print, so they you see also firmware enablement. They had here print somewhere. It should be. What do we even? PicoSoc should be. Where is our print? Here's our print. So you see this is a serial console printout here, and they don't have any format modifiers like %D and X for decimal and hex. What they have here is instead a very custom print hex and custom print decimal, which only supports numbers up to 1000, as you can see. Due to the simplicity, I can tell you another video why. And what I've done here, because this results in not the most pretty code, here you see, can we also cancel this search here? It's a little bit inconvenient. Print text, because it doesn't support format modifiers. Print decimal, print new line, of course a little bit, nah. Of course I totally understand why they've done this, and I can tell you tomorrow maybe why. Getting a little bit too long for this video. And because for the first testing here, this was of course okay. Here in our firmware for the text mode and mouse cursor testing there, which may or may not be on the screen, barely on the screen. And of course for the first testing, just like what they had, this was okay, but in the long term it got a little bit on my nerves. So making upstream better, I copied from our DOS vintage code here, our custom Printf implementation over here. That of course worked. This is not that. Here this of course worked. Unmodified, this is also the code repository I want to build up here. So some Rosetta code like of archiving. Of course keep it stupid, minimally simple. And I asked the authors of PicoSoc, Pico RISC-V, if they want this Printf, and they said, yeah, sure, bring it on. So I spent here also just 1 hour. Maybe I should have live streamed it, but maybe not. Always a little bit boring. This is from the DOS Verge Voodoo low-level bare metal code, the Printf that we hacked there for the 64K, straight from GCC or Clang on Linux to DOS bare metal stuff. And there you see making the open source landscape. Of course, there are many Printf implementations, but the glibc is huge, the diet-libc medium. It's of course also nice to, although there might already be some whatever, but it's also nice to have here something in the public domain. And so yeah, I cleaned this up a little bit and also started, because the next thing is also implement. You see everything you need to implement, certainly if you have your own operating system or firmware. You saw here, if you want to get something working, then you just do it here with single print, the most simple thing, because otherwise if you have something more fancy, then you need to start parsing this format modifier stuff and then implementing everything from filling zero to precision to width of fields, everything you certainly need to implement. Also with our security stuff, certainly. This is exactly this kind of code that I'm not the greatest fan of, writing it here myself. Should everything a little bit more, yeah, not as direct buffer modifying and easily crashing, but anyway, need to think how we make this a better thing. But I cleaned this up a little bit and optimized it and started and prepared it to implement zero padding and filling and width, because all of those details need to be implemented. Would be interesting to see, so we have some people tuning in. I mean, as long as my wife is not calling, we could implement it ourselves. So this is, Glaucus is asking what libc are we using. So we are using no libc. This is the entire firmware in one file. So this is, so basically no libc, which is why they had print implemented themselves. And the whole firmware is one C file for this RISC-V FPGA testing. And I only modified it, adding here the cursor, the VGA testing from the other day. And also this actually has twice the memory of Commodore C64. We have here whopping 128K of memory, so also even in my opinion better than a DOS environment because we have no segmentation, so linear flat addressing, much more convenient. 32-bit even, so in my opinion much better than 8086 or 286 or something. Some other stuff I've done, so I said this is the last video, the text was flickering. This was a super simple fix that was simply, I had here the dual port RAM clocked from the wrong clock. This is why the address lines were not updating as often as they should. I actually, while I was, maybe I even mentioned in this video, is this the right clock? I think at one time I might be like, is this the wrong clock? And of course it wasn't, because the pixel clock is some 26-ish megahertz here, and the other clock, the main clock, is 12 megahertz. So this of course was why this was flickering like that, because just the clock of the memory wasn't the same. So the address and data lines were out of sync in regards to the clocking signal. So getting this video signal stable and working and stuff was just a matter of supplying here the right clock. And then in contrast to the documentation, I think I read somewhere, as I mentioned in the previous video, that it isn't supported to initialize this memory in uses. Apparently either this changed or this comment was wrong. I changed this here right now, hard-coded to, because it's a module, we instantiate this dual port memory here twice. Just is a little bit of a hack. I need to read in Verilog if we can have this somehow as parameter, like some kind of, yeah, there are parameters just like something of this sort here. PLL or this PLL. Anyway, what I meant is initializing this. So right now I have this hard-coded that saves us having the 4K of character data. In the previous video yesterday, we had this embedded here. I moved it here, custom character set. If you want any, I could remove this code again, because certainly it's not nice in this constrained vintage retro homebrew-like environment to waste 4K or something for a character set. Of course, if we have these bits in the FPGA bit stream, why not use them? And to my surprise, right now it looks like this works. Here, as you can see, that means the character set here, all the characters are initialized by power on default in the FPGA, encoded in the bit stream, and not wasting any bits in our precious flash or memory there of any sort. That of course makes the whole environment here already much more amazing and easier to work with. Also here just-in-time compiled kind of code here, working as previous video. That means of course in the long run, as you have heard here, I'm quite a fan of Lua. Certainly much nicer to work with than BASIC. This also could mean if we not only write our own small Lua virtual machine, also maybe potentially with RISC-V code generation, that certainly would rock majorly. That is a global picture of the 20% after work time here spent on this fun project that week. The code, for example, the Printf stuff that I improved here for this project, I will move over in this DOS repository. So I will, we have there already Voodoo 3D acceleration and Link 3D from the fun projects here of ours. And although this Printf stuff is not the biggest innovation, this kind of stuff I want to collect there the most minimal readable examples of code then for use with firmware, not only on this RISC-V but also other like Blu-ray, disk drive, or any other kind of tinkering stuff we might be doing here in the next years, or PS3 boot up, or our microkernel stuff. So like we certainly, if we want a full digital self-reliance of not using any other's code, only here 100% our own code, certainly for our microkernel, also Printf nice to have. Welcome everyone. So yeah, also, so next I will send this upstream here, then making this firmware nicer. Of course you can work with this, as you can see. This is certainly how I would also do it. I could also actually, do I show? Okay, the reason they have most likely done this is that if you have a totally minimal firmware, and the issue is we don't have a hardware divide and multiply for space reasons. Pico RISC-V does support this optionally. However, we don't really have enough logic elements on the FPGA for hardware divide and multiply. And this is also why they most likely have this poor man's implementation there of this stuff. Because I have here, you see, you might have noticed already, I have here some software divide and multiply. Let's comment this out and I show you why they most likely didn't bother to have a full Printf implementation and this oh no, darn it, I think I saved here something for some reason. Buffer modified kill unifiers. Get diff, didn't want to update this VGA. Yeah, oh wait a second, this is, I didn't want to resynthesize this. Yeah, VR, of course, then icebreaker firmware.elf and also path. So what happens now? I was somewhat surprised myself. So that happened when I copied the Printf code over. This happened. Undefined reference to mod si3 and diff si3. These are library software multiply, modulo, and divide routines that usually are in libgcc or in LLVM-CLang in compiler RT. On previous videos on this channel using LLVM-CLang for a Linux system or DOS stuff. And then I was looking at this like, yeah, okay. This happens also if you assemble this like maybe so, verbose ASM and udiff. So if you look into this disassembly here, or the verbose generated compiler, you can tell GCC output verbose assembly, so like instrumented where all this stuff is coming from, and you see a call, so int to print here in this RISC-V registers, and then call udiff se, and this happens because, of course, again, we have a Pico RISC-V configured without hardware multiply and divide, and then of course, as the CPU doesn't do this, cannot do this, then we need to do it in software, similar to a first version Spark from the beginning of the 90s, Spark version 7 or something, in our mighty Spark station there, also previous video. So this happens here, int to print in our Printf. This most likely is also why Printf here and int to print. So why, I'm not sure if the authors of the PicoSoc have tried this and they're like, yeah, okay, well, okay, then maybe not. This is this into print, and for outputting here 10 base numbers, we of course need to divide and modulo by 10. This is where this is generated. So this is why I had here, the issue is I don't have a matching libgcc here, so you could probably maybe or you should be able to use the libgcc just because of this cross-compile environment. I don't have it around here. You can of course compile the matching one for the right processor specifically. This is why I included here some diff SE, some really poor man's divide. Totally, maybe this is a topic of another video if you want to learn and see details how to implement a totally unoptimized, and yeah, so this is the fun stuff you do, and this probably gets too long for this video. Just in case you were wondering why did they do this so bloody annoying, that is most likely one reason why. And you see this is routines in there, this assembles and links, and so this is questions audience, what are we hacking and why? We learn FPGA stuff because I figured it's total fun. It's basically as much fun as I thought it would be. Totally amazing. This is open source firmware, so this is open hardware. Again, previous videos if you're new to this channel. Icebreaker FPGA board with open source uses, open source compiler chain, and I find this again pretty much fun, super entertaining and educational. Hope you learned something, and if you have any comments, questions, and if you think that's a cool homebrew system for all kinds of homebrew or professional microcontroller RISC-V needs, then leave in the comments below what you like to see. Also next, keyboard, mouse and sound. I changed to finish this here a little bit. In this printf next, I would also like to have fields. Maybe let's quickly try to do this. It's only a pity that we maybe we synthesize here this Verilog in. Let's hope I didn't break it. Git diff of VGA. Did I pix clock and outdater? I'm actually surprised that it maybe understands the semicolon there. Let's see. So what I next, also to make this more full-featured before sending it upstream to the authors here of Pico RISC-V, that although probably with our IT security stuff, this kind of C formatting stuff should maybe be avoided. What I would want to implement here also is zero filling. So actually what we could do is I have here this formatting. Maybe if you want to see totally low levels here, so that would be the code that usually is in some C runtime of C library. And zero, I was thinking, so I already changed this quite a bit from the DOS code of previous Voodoo Verge. If you're interested in low level 32K 3D acceleration on hardware isolated on Verge and Voodoo. I would like here width and zero filled with precision stuff. Right now, so I changed this already. We have here a temporary buffer for outputting this. Also, this should ideally be some dynamically sized something or whatever. Right now it's maximum 23 because 64K DOS environment. And just checking a little bit, the problem is also usually this setup is slightly more amazing if I don't need to scroll left and right due to having this here on that screen. So that would be, I output this in this temp buffer. Right now I fill this temp buffer in reverse because until earlier today I was recursively, or so to say, calling this as printf again. I changed this already to output this here in custom loop. So now we would have, if we have zero, so for example we could, so the only issue is we have here, this is the size, so the problem is, so we fill this, so the issue is, well, it's not really an issue, but whatever. We could theoretically, so simply, we already parsed this zero filling stuff. So zero, if zero, let's see, what would that be? So we have, do we have, yeah, we have width. I think that could work already. So basically if we have a width specified here in this format specifier, then fill this stuff. Maybe we have here in const int width or equals, so we have this here somewhat in reverse. Maybe it might be easier to read and write if we just incremented some in this temp e, but right now we fill it from reverse because if we are dividing by 10, we are basically like 1, 2, 3, 4. We are doing this from the reverse. So basically we modulo 10 is 4 and 4, and so this is why if we go through this number and always divide by 10, we generate this in reverse, which is why I'm naturally filling it in reverse like so. That is why this is reversed, if that makes sense. So that would make the width here, the created width size of temp minus the temp e, and so that should be, I mean, we will see in a second. So then we could fill this, that means for e equals 0 less than with minus w plus I, and this would be outputting here either zeros or if 0 padding, then 0, otherwise a space. That might or might not work already. If you have questions in the audience, would be really curious to say, to hear what you think, if it's worse. I mean, for me, it's also still a learning experience. Of course, we have done here quite some low-level embedded stuff over the last 20 years, but bringing an own platform like your own SoC, your own CPU, although this is upstream PicoSoC, but nonetheless working here basically with, as if you design your own processor and things like that. Certainly pretty interesting. So did we break our, I mean, we are still outputting something. This SPI state is outputted by this RISC-V, not by this printf, sorry. So yeah, this works. Then let's still not completely broken. Let's try or did I even save this? Or maybe I didn't save this because Emacs. Oh, okay, I didn't save this. That explains why it didn't break yet. 0. What does the compiler say? 0 undeclared R. Maybe this is in the wrong scope here of that. Then we need this for in this scope. Zero undeclared are zeros. Okay, fine. What error? Zeros. Let's see if we completely broke it again. This, by the way, is the time it needs to flash this over USB, the FPGA bit stream, and our C firmware. Looks like it's not yet completely broken. Let's see if we can use padding now. Here in the cursor printout, for example. That would be, or JIT, or doesn't really matter though. Let's do it for the cursor. The cursor output is here, so that should be 0, 4, 0, 2, just to test here two variants. And yeah, maybe we just test it like this and see. Oh, wait a second. We can directly test also the the non-zero field width, like also 2, just for the fun of it. That should leave spaces there. So let's test both in one go. So what do we have here? Hey, and we have something. It looks like it even, no, it did not completely work. So Oh wait, no, maybe this worked actually. It worked somewhat. No, it works completely. Just irritated me. First oops, stupid mouse bit scrolling. No, it looks like it actually works on the first try, so 008, and here spaces, so fantastic stuff. It's not always that it works on the first try. So yeah, we also made this greater again. And the best thing, so in the future I will move all this code in, so of course I will send this upstream, because why not? We are using the Pico RISC-V, amazing RISC-V CPU, certainly a huge achievement and nice to give something back, which in general I always encourage everyone, send some patches upstream and stuff, also if you want to see this. Next, I mean, we basically also could start to make this a real BIOS, like a real firmware. My wife did my call, so we could theoretically make this here a real, like printing out this Pico sock here. It's basically VGA if you want to see something cooler than that. This is just a matter of VGA. The only thing is here some initialized variables don't quite work, like static. Something is probably with this linker and enablement. Which by the way, maybe I just commit this here already. So use, oh no, this is VGA also. We had, by the way, a typo here. I committed this actually with a typo in this pixel clock thing. So yeah, so oops, commit fixed dpram pix clock typo and initialize char set VRAM again, initialize, looks okay, good. Actually meant to commit the firmware though. Yeah, of course diff, why? So let's see, precision, you see this was surprisingly simple now. Actually, although I cleaned it up, I didn't even expect it to be that simple. And yeah, banner cursor, whatever. Doesn't really matter, just for my backup here. Commit, implement, print fields with and 0, fill plus example code, whatever. So to make this output, to make this look like a real, like Commodore, I don't know, something, Archon, RISC machine, something, we can simply VGA to output this to the VGA. We could also the font, now whatever. Maybe actually we test if that still works, because earlier when I had some variable here, it was somehow put maybe in some wrong section or whatever. Let's see if that still works, just for the test of it. And so we can probably close it, that we have less stuff here. So screen, yeah, this does not work because reason, exactly what where's our JIT code? So const, this const stuff does work, so okay, something is up there with variables. I expected this already. I slightly wonder why though. But we can, okay, this is slightly inconvenient though for, why would this not work? Flash IO worker, where is it even? I mean, we could disassemble that certainly. Object dump, firmware, although we don't have the symbol there. Do we have? Probably not. Or we have, so it puts this here somehow in the data section, and where would it, why does it say unimplemented? Unimp? What, VGA font? Why does it say unimp? It's disassembling this. I think it's disassembling this. It's just mean. Okay. This is a little bit inconvenient, really. Flash IO worker, why does it have Flash IO worker begin linker? Maybe there is some, oops. Where would they have this in? What was a comment? They have this in extern SRAM pointer to the null pointer, but the compiler doesn't know this in sections LD. Sections LD. Where do they put data? The program code and data goes into the flash. Maybe we cannot. Maybe it's in the flash and writing too. Does it make sense? Because to output this on the screen we need some kind of pointer, and that can we the static changes thing. Not that it makes such a big of a difference. Certainly I should, to make this more convenient, certainly should find out why exactly that doesn't work. Okay, this static appears to work for whatever linking limitation reason there. Because we need, although those actually could be const pointers, but whatever. So let's make it static VGA X equals 0 and VGA Yep, that happens when you stay in the office too long after work. So to print this would be, can basically put char, you know what, maybe because everything is printed out with this put char from upstream firmware from PicoSoc fun, we could just modify this to also additionally print it to the VGA. So that would be VGA something. What was it? VGA, what do we even name this? VGA VRAM? Yeah. VGA VRAM at location VGA Y multiplied by 128 plus VGA X equals the character. So we need foreground, background color. That would be just, for example, foreground as a first, so 0 is black anyway. Let's use probably 8. Should probably something like, or 7 maybe. So that hex and should probably be like that, because, okay, read, and this is slightly, so, and the character, and then if it's a new line, which actually if it's a new line we shouldn't print it actually, but yeah. It's for new, for now let's just print the new line also, whatever. So in any case this VGA XX we need to increment, and for a new line so this other additional stuff is also for the UART, so we print it to the UART in the VGA screen. So VGA VRAM X 0. So if it's a new line, then returns a VGA Y++. Actually, I usually use, oops. So that probably could already, of course, not colors and whatnot, but let's see if that comes out of the screen. That would probably already would look more like a BIOS firmware thing. And we have something on the screen. Not too bad, right? So one thing is we had, why is it so? Some is definitely new line, maybe SS. So yeah, certainly in one super simple line of code already. This is also not the most, also Also, yeah, this is off by 1. This is still preloading. We need to fix this VGA memory access stuff another day. Some stuff here is just new line. So this double stuff is just this preloading stuff in the beginning, whatever. What would that be? Pico. So that is some lines. Why would they not come out correctly? Not sure actually. And then of course we should theoretically sorry. Also, I mean, theoretically we should scroll this, but scrolling would copying all the VRAM over. Actually, theoretically we could even implement hardware scrolling by having some variable offset there for the start of the data section to make this scrolling CPU time limited. Maybe we implement this the next time also. Hope that people find this as interesting as I do. So scrolling would otherwise be copying everything up, but otherwise we could simply, if VGA-Y becomes too large, so we have right now 30 lines, so if it becomes over 30, then reset VGA-Y to 0 to simply also, okay, this would still not clean the screen. Actually, this is also, yeah, this is just a poor human's quick hack for that, because it doesn't clean the screen. So unless actually maybe, yeah, maybe we should, yeah, anyway, it doesn't really matter too much. Maybe we should rather implement scrolling. Anyway, scrolling will be probably, whatever. Leave in the comments below what you like to see the most. Until then, let's see if, so the only thing is we don't have clearing of this now. Actually, you know what, we could actually, I mean, but this is really cool, right? I mean, this is already with some timing here. Not really sure why. So this is certainly, must be the new line, I would think. It should be. Not really sure why that is so distorted. Anyway, total memory. Yeah, so this must be the new line character there in the text character. Not really sure. Well, maybe we have. Maybe this is 0. Maybe this is something like 0 character from our Printf or something of that sort. The devil is always in the details. But yeah, this certainly makes this look already much more like a Commodore C64 or any other kind of fun stuff. We could actually fix this quite a bit by clearing the end of the line here. So basically, you know what? This is even this is calling itself. So this is put char for UART data that explains this. So then let's make it just like that. This way we don't have the extra new line printed out there. That is somewhat annoying, to be honest. And then here this there is so here we could clear the end of the line, so to clear excess stuff while scrolling, for VGA x less than 128 plus VGA x, and setting here, setting here this to a black nothing. VGA, of course, yeah, this is not super highly optimized. Maybe the compiler optimizes this away, if not, whatever. Yeah, the problem is, darn, I didn't show this for some, sorry for that. Always when we don't have the most, probably need a third display here for, and now we have, why don't we have, now we have a new bug. Also this explains a thing, maybe. So theoretically, usually I try to prefer this while to make increments more visible. We had this increment here already, that explains why something was probably, but is this all VGAX? So if a new line fills the rest of the line, clear rest of line, VGAX less than y multiplied plus this should look okay though. Let's see if that was everything. The cool thing is that we could have a whole system emulation, including so running the synthesized Verilog in an emulator timing model plus having all our firmware on there. Why is this not printing correctly now? Or did I remove? You know what? I cutted this. Nah, stupid for me. Super clever. So only live on YouTube, cutting my precious code away. So that the new line. Of course, a real implementation would need some better handling. I mean, except scrolling, also maybe potentially handling getting over the X coordinate, but probably just wrapping is somewhat kind of, if you were wondering why the PC BIOS sometimes had strange glitches like that, then that probably could be why, because whatever, just don't call it like this. Yeah, again, this double character is our known off by one stuff. See, jitting this here, you see this clears now correctly. And yeah, this is also, probably I'm not showing the best view as usual. Pretty fun stuff here, right? We also have the echo UART, so can you already type? Where would this be? Like, let's see, this is a test. How can type on? Oops. Also, yeah. Again, VRAM access time. Some stuff is not correctly clocked there, but that is a topic for another thing. Yeah. So that is already pretty cool in my opinion. Fun little project. Leave me in the comments below if you would find an homebrew 32-bit this video output. Also need to check with Eston if we can, I mean, hope I'm not the only one who finds this cool. Anyway, yeah, so RISC-V, there we have it. Maybe I should do some benchmarking and see how this code, how fast this is running, how it compares to an 6502. However, we have not only not 8-bit, we have 32-bit. And so we are running at 12 megahertz, not really sure. So the Pico RISC-V is not sure if it's probably not doing one instruction, not really sure how many instructions it's doing. But yeah, next, as you see, this is so much more satisfying to have here real amazing stuff running, like real text output, graphic output, theoretically already a mouse cursor of freaking feature overload. Due to that, I will probably fix this tiny little off by one data latching there from the memory last, because, yeah, whatever. Also, hey, run memory test and stuff. Where's our memory test here? In memory test, our memory test is what? Oh, capital M. Running memory test, sending, where is it even? This is past. Unfortunately, this past is scrolling away here. Anyway, because implementing new features is more amazing, next is certainly keyboard and sound. And so most likely AT-PS2 keyboard stuff and sound, some PC peeper, speaker, Tandy-like, something, hopefully Tandy-like 3-4 voice, something that would be cool. But soon we also do other stuff, because before other people, everyone else is unsubscribing, probably better unpack the SJ Octane or P3 for one of the next videos, not to mention latest and greatest product reviews. I'm certainly totally happy with my achievement here, and also making upstream stuff, sending this Printf stuff upstream, because sharing public domain or whatever license upstream this was. Code there of most minimal. What is it even? Also something, this is BSD, whatever, YOLO. That's it mostly for today. We have at least done some somewhat cool stuff. And I hope you like it too. And if you would be interested in spinning some hardware production with, certainly not ourselves, but need to check next with 1BitSquared if they are interested in some specific microcontroller higher spec version. The fun thing is there is a lattice, some 8K something. Would also be cool to have a slightly larger FPGA, because with a slightly larger FPGA, more video sprite goodness and more audio tone generation goodness. Anyway, looking for your comments. Need to go. Hope to see you soon, and don't forget to share, like and subscribe for all the next videos to tune back in.